looking forward to it. Thank you.
Thank you very much. So as you see, this is work done with my old collaborator and friend Katsuhiko Sano from Hokkaido University. There is a bit of confusion here with style of the slide. So at present, I'm already affiliated with University of Naples, but most of this work was done when I was still I'm still formally privat docent at VAU, and my student from Maxwell Liger, with whom I'm doing complementary presentation this afternoon, helped me with his slides. So, and I was too much of a mess to edit the style. So you have 3 universities here. How can I change the page? Okay. Okay. All right. So Inquisitive further logic sometimes is presented as an extension of classical logic with questions, but one may say it better by saying that it allows to put it allows one to put declarative and interrogative statements on uniform footing. So apart from and reason about dependencies between them, for example. So for example, apart from ordinary statements like saying that Luisa is guilty in this example, we can also reason about things whether the fact that Luisa was there allows us to infer, or do we know whether Luisa is guilty? Or if we have settled the question whether Luisa was there or not, do we also in this way settle the question whether Luisa is guilty? And is there some person, regardless of state of our uncertainty, can we say for sure that there is one fixed person that would be guilty? So instead of just being supported by a single first-order model, formulas are supported by sets of possible words, which are first-order models. So here you see several possible configurations of this being guilty and not guilty, and being there and not being there. So if we look at the sentences from the previous slides, and if we look at information states, we get depending on which set of possible words of sets or first-order models, different sentences will be supported or not. For example, if we're looking at the collection of words corresponding to first-order model 1 and 2, those two models settle differently the question of Luisa's guilt, but so in this way, the implication between us knowing that Luisa was there and being able to infer whether she was guilty or not is not supported. But if you look, for example, at these two first-order models, so first-order model has collapsed to a single individual, the fact that Luisa was there, if you're looking just as this information state consisting of these two first-order models, allows to settle the question whether Luisa was guilty or not, and so on and so on. So standard first-order stuff, and one can do it in full generality. In our paper, we are dealing with the simplest possible first-order syntax, namely purely rational one, without function symbols. But if you look at standard references like Ivano Ciardelli's book and most of the publications, one discusses in full generality more complex individual terms. If you allow function symbols, for example, you have to agree with which one of them are rigid and which one of them are not, meaning that they fix that we consider the denotation of corresponding function constant fixed across all those possible models, which are our possible words. And syntactically, what is happening? Well, one could, in fact, think of of inquisitive logic in two different ways. So one is to think of it as an extension of classical logic with two new connectives. So apart from standard disjunction that you get in the standard De Morgan way, you also get this new primitive, which is inquisitive disjunction. and you get the existential inquisitive quantification. But another perspective on inquisitive logic is to look at it as a very weird superintuitionistic logic, where you have where you are not closed necessarily under substitution, because, for example, you have of course to be precise, as we're going to see later, what substitution means in first order formalisms. So not substitution just of individual terms for variables, but also substitutions of formulas for predicate symbols. For example, in inquisitive logic, the law of double negation is valid for atomic formulas, but not necessarily for complex ones. And you can relate these two views, and then this disjunction would be just ordinary intuitionistic disjunction, just like you get in Kripke, intuitionistic Kripke frames, and this existential quantification will be ordinary intuitionistic existential quantification then. And of course, one can bridge these two perspectives, or you make this dualism, particle wave dualism, uniform by using, or settle this by using negative translations, in particular Gödel-Gensen translation. So this is in fact one of the first things that got me interested, apart from Katsuhiko consistently dragging me into it. So I already said somewhat informally how models look like. So this is the formal definition. As I said, the set of possible words is really the collection of first order models, and we have rigid function symbols which are interpreted uniformly on depending regardless of the word, and other ones in other cases the notations can vary. So the collection of individuals is fixed. This is what also provides a connection with very specific superintuitionistic logic, namely of constant domains. But the interpretation of terms of constants, those are the ones that are not rigid, may be different, and the interpretation of predicate symbols, of course. And so then when you look at the state, which is a subset of this collection of models, you interpret atoms, as we're going to see probably on the next slide, simply as an intersection of the notation of predicate symbols in all individual models belonging to that word. Right, no, it wasn't here. Right, exactly. So here it is written in a different way. It is here we have that support. The support relation is interprets a predicate symbol over a state given a fixed valuation of individual variables. Of course, using universal quantifier, but another way to put it is just to intersect all the notation. And well, other things are standard. So, for example, you force bottom only if you are empty set of individual words. Implication is here you see this connection with intuitionistic logic, because you really you scan all the substates. So your intuitionistic order is the inverse of partial ordering of states, and in a given state you need to scan all the substate to say that the implication holds. Disjunction, well, it has actually the same interpretation as in intuitionistic Kripke frames. Here we can write this universal quantification in this way because we are living in the constrained domain world, and existential quantification is, as you see, interpreted by is holds in those states where you can fix one individual that does the job regardless of the individual specific model, specific word in that state. So it has to be chosen uniformly. Just like the disjunct of the in disjunction of the inquisitive disjunction has to be chosen uniformly. You either go for a phi or either go for a not phi, for example. But it cannot be that one word in your state forces phi and another forces not phi. Then the excluded middle fails. So there are several standard properties that you would expect, which are intuitionistic properties. In particular, you have this property of persistency. Well, we have already seen that empty state forces all formulas. And as you would expect, truncating the present relational information model to the just to the substates of the present state does not change the true value of the formula at this particular state. So the broadest system is then inquisitive logic, that first order logic determined by all such possible models, and that there is a natural deduction system by Charelli and Griletti, which might turn out to be complete or not. I think it's still an open question. And then the question is, what happens when you restrict not the size of the domain of individuals, but the collection of the possible words? So you have only, let's say, finitely many, maybe you restrict to 2 possible words, or maybe you restrict to just 5 possible words, and you only have finitely many alternatives of how things can go. As I said, the collection of individuals themselves may be still infinite, maybe even uncountable. And this is how you get so-called bounded inquisitive first order logic. And in fact, Charelli and Griletti extended the natural deduction system to bounded variance for every single fixed n, and proved the resulting extension to be complete for most signature. But the axiom they had to add was extremely signature dependent. It was so-called cardinality formula. And if you want to call this thing still natural deduction system, then pretty much all the properties that the proof theorist would expect I guess, would suffer. So this is, if you have just one predicate in the language, this is how you generate this cardinality formula recursively using cardinality formulas for smaller n, and using just this one predicate symbol that you know to have in the syntax. Then you do different things if you have the function symbols, and you know that all of them are rigid, so it's heavily signature dependent. The axiom would still look very differently, not even necessarily following the same pattern, if you have, for example, equality in the syntax. And well, whether you look at whatever Martin Love or Costa Dojan or Sequent guys would normally require from well-designed sequence systems, probably they wouldn't be happy for when such axioms are done. But as I already said, inquisitive logic cannot even meet a most standard Hilbert-Style criterion, which would be closure under uniform substitution. So then the question arises of schematic validity in inquisitive logic. What is this? It's schematic core or fragment, meaning the largest standard superintuitionistic logic closed under substitution containing it. And as long as one is dealing with propositional formulas, all of this will already beautifully settled, as so many other questions by Ivano Charelli. I think he did it still in his master physics period. And he just established that the schematic fragment of propositional inquisitive logic would be just so-called Medvedev logic of finite problems, or finite topless Boolean cubes, if you look at its Kripke semantics. So you take finite Boolean lattices as your Kripke frames. Okay, they don't have to be topless. You can leave the top, but you remember that the top forces everything, including bottom. So it's deviating from standard intuitionistic interpretation. And on the other hand, we know that propositional inquisitive logic can be obtained as negative counterpart of Medvedev logic, namely as the collection of formulas whose negatively substitute variants, where you replace each atom with its negation, belong to Medvedev logic. And to the best of our knowledge, there was, even though Ivano has explored a lot of roots and also Griletti, I don't think that they were attacking those questions so far. Of course, this requires as a prerequisite going to the exercise of, as I said, formulating a suitable predicate notion of schematic validity and for substitution for predicates. And there have been many such attempts, successful ways of doing so, but of course there is quite a bit of bureaucracy that you have to take care of by Ono Sensei, by Church himself. There is also this notion of scheme, which has some flavor of being locally nameless in Gabay Sherman's course of book, and the standard reference by Clini, which I think is still the more perspicuous and straightforward if one wants to get one's teeth into it. So this is the main slide. Even if I run completely out of time, I would be happy if I cut off here. Well, I wouldn't be happy, but at least it wouldn't be as bad as it would be otherwise. So our main achievement is providing a Sequent Calculus, labeled Sequent Calculus. Sorry, I should have written clearly that it's labeled, where labels are finite sets of natural numbers, which of course correspond to those individual words, and which we prove to be sound and complete for each n-bounded logic. We managed to prove, well, mostly Katsuhiko, of course, prove cut elimination and admissibility. And the calculus at least provides at least a sufficient characterization of schematic validity. The very obvious one. If just one specific rule for atoms is not used, then we know that that all these schematic instances, whether you use Clini definition or any other one of the formula derived this way, will be also valid. Yeah, so as I said, labels are finite natural numbers, sequence are what you would expect, and then you interpret things by mapping natural numbers to individual words. And as I said, the setup in the paper for simplicity is restricted to purely rational signature, no funny business, function symbols, complex terms, rigidity, blah, blah, blah. But there is also a somewhat adapted version suggested by my former student, Maxwell Liger. And he was able to cover non-trivial rigid terms, and it was done hand in hand with his Nast and Kokorok formalization. We didn't check so far whether these extensions are breaking meta theory. So far in our formalization, we were only able to prove soundness, which is of course not much. So this is this thing in the whole glory. I would like to torment you with it for a while, but maybe you have the paper anyway, so it's just copy and paste. So anyway, those x's here, those x's and y's here, as I said, finite natural numbers. Most of other things are what you would expect to see in labeled Sequent Calculus for first order logic. Including the rules for this funny new connectives, inquisitive disjunction, and existential quantification. And then there is this rule for atoms, right, which is the only one where you don't have these Greek letters ranging over all possible formulas, but just atoms mentioned specifically. So clearly something can go wrong if you, with schematic validity, if you have to use this rule, but other ones really don't care about, and of course you can prove it formally, about as long as this atomic rule is not clipping it somewhere. It's our tentative conjecture that actually this is sufficient and necessary characterization, but that's a bit tall order. That if you don't use atomic rule, then you are schematically, the derived formula is schematically varied in those bounded fragments. Right, so, oh, actually I should have probably moved this slide a bit earlier, because at least it explains this funny business with classical laws and not being closed in substitution, whether in the propositional case or in the predicate case. So, as I said, for atoms, this is a theorem, but even if you replace, so again, as I said, one has to be specific what it means to replace this letter with a formula in one variable. Then you get with instance of excluded middle, where you don't use this De Morgan disjunction, but actual inquisitive disjunction, then things can go funny. And you don't even need to go very far already in two bounded, where you have at least two possible words or two possible ways of how things could go. You will already break this thing down. But what we were playing around with, both on the sequence style and on the semantic style, was so-called Casari scheme, which only probably the people who really like superinductionistic logics know about. But when you're living in the predicate setting, you can really play funny games with this axiom schemes, and they will sense presence of infinite ascending chains, infinite descending chains. I mean, all kinds of things that normally it's not possible, are not possible to do when you're living in propositional inductionistic language. And as you see, you have a bit similar situation as with excluded middle. Atomically, Casari scheme is valid even in the base inquisitive logic without this whole boundedness funny business. But if you look at the instance where you are using inquisitive existential quantification, and well, I wasn't able to find a counterexample involving unary predicates. Maybe it is somehow possible using so-called Kripke trick, but would be much more complicated. Then suddenly things break down. So the Casari scheme actually happens to be schematically bounded valid, and this is where one can play around with the, one can of course try to prove it semantically, but one can also use the Sequent calculus and or even the Skok formalization if you hardwire cut elimination into it, because we didn't prove cut elimination, and the derivation requires cut. But it is not schematically valid. And as I said, my original proof, which I was kind of proud of, I thought it was a bit of nice nomotopletic construction. And I had to fix it once. I noticed a subtle mistake. And then my students spent like 2 months fixing it. And then TABLEAUX referee proposed a dramatically simplified version, which I prefer not to check. I still prefer to believe that this person was wrong. And I have this Skok formalization. I can convince myself that that person was right, and that would break my pride completely. So, yeah. So this is a quick summary of what we have achieved so far. We have cut-free labeled calculi for n-bounded inquisitive logics. We illustrated the intricacies of schematic validity, showing that Casari is atomically valid, fails to be schematically valid, but is schematically valid under finite bandedness assumption, even if you don't fix a single specific n. We have calculus, which captures this notion of schematic validity. I couldn't discuss it here, but you can look at the remainder at this paper. We can capture entailments with so-called restricted existential conclusions without additional rules, and maybe we are beginning to see benefits of working with a NAS and Kogorov formalization, about which I'm going to talk more in the afternoon in adjacent room. There is lots of future potential questions and future work. So of course, given that we have cut elimination, one would like to look at how to derive quickly Craig interpolation from this kind of results. There was a lot of work in this heyday of superintuitionistic predicate logic, including my PhD supervisor, Ono Sensei, about model theory of extensions of logic with constant domains. And some of the questions that were tackled therein, like Lovenheim's column results, are quite similar to the questions that Ivano was posing in the context of bounded or not necessarily bounded inquisitive logic. We still need to try to attack, or see if our formalism can be used in attacking the challenge on algorithmically identifying formulas coherent for a given cardinality. Extending existing computational interpretation of sequent calculus to this setting, I think that that's something that already, I think Johannes Marti could have stabbed, and that was looking really promising. This work was never continued, and it should. And there are other connections, potential connections with database theory, like the hinted at by discussion of Armstrong relation by Abramsky and Bananen, Ciardelli's perspective on mention some questions, but this is something that I really would like to spend a bit more time on. Okay, so this is it, and if you have questions.